It's been a few months since the last Starship launch, which lasted about 50 minutes before burning up during re-entry. Many of us thought SpaceX would need a long time before attempting another launch, but they've surprised us again. We're now about a week away from the fourth launch, according to Elon Musk himself. However, as they get ready, they've hit an unexpected snag with the Raptor engine, which might affect their launch schedule. Before we dive into that, please subscribe to our channel for more updates on Starship and SpaceX's other amazing projects. On May 23, a Raptor engine exploded during testing at SpaceX's facility in McGregor, Texas. The explosion was pretty big and might have caused a lot of damage to both the engine and the test stand. SpaceX hasn't given us a detailed update yet on what caused the explosion or how much damage there was. Raptor engines go through a tough testing process. They are made, tested in McGregor, and if they pass, they go to Starbase for installation or back to the factory for future use. The engine that exploded is believed to be a Raptor 3, as most current prototypes use Raptor 2 engines. The Raptor engine series has evolved from Raptor 1 to Raptor 2, and now to the more powerful Raptor 3. The Raptor 3 has shown incredible performance, achieving record-breaking pressures and thrust. SpaceX started working on these engines several years ago, with the first Raptor 1 tests happening in the mid-2010s. Raptor engines use liquid methane and liquid oxygen, which makes them very efficient. SpaceX didn't want to rely on traditional aerospace suppliers, like the Russians, so they created their own engines. This led to the development of the Merlin engines, used in the Falcon 1, Falcon 9, and Falcon Heavy rockets. These engines use kerosene and liquid oxygen and operate on a simpler system. Over time, they've been improved, with the Merlin 1D being one of the most efficient engines available. But for Mars colonization and deep space travel, SpaceX needed a more advanced engine. This led to the creation of the Raptor engine. Raptor engines use methane and liquid oxygen, which can be made on Mars, and their design allows for higher pressures and better efficiency. They can be used in both the Super Heavy booster and the Starship spacecraft. Currently, Raptor 2 engines are used in Starship prototypes and have been part of all 3 orbital launch tests. They've performed well and are key to SpaceX's missions. SpaceX has conducted 3 orbital test flights so far, 2 in 2023 and 1 in 2024. For the 4th launch, SpaceX plans to launch the Super Heavy Starship into orbit and attempt to land it on a virtual tower. This means the Starship and Super Heavy will perform a controlled landing in the ocean, hovering over a specific point until it runs out of fuel and falls down. This method has many advantages, similar to how they practiced landing the Falcon 9 on a drone ship. Landing rockets is one of the hardest parts of rocket launches, especially with larger rockets like the Starship. The Falcon 9, for example, is 70 meters tall, has a diameter of 3.7 meters, and weighs about 549 tons. It generates around 7.6 million newtons of thrust with its 9 Merlin engines. Landing the Falcon 9 took several attempts before SpaceX could reliably land it on a drone ship. Falcon Heavy, which is even more powerful, combines 3 Falcon 9 boosters, making the landing process even more complex. It stands at 70 meters tall, has a diameter of 3.7 meters, and its first stage consists of 3 boosters. The combined thrust of Falcon Heavy's 27 Merlin engines is 22.8 million newtons. Managing this immense power during landing was a huge engineering challenge. Now, consider the Starship. This rocket, including its Super Heavy booster, stands at 120 meters tall, has a diameter of 9 meters, and weighs about 5,000 tons. It generates a staggering 72 million newtons of thrust with its 33 Raptor engines, a colossal increase compared to the Falcon family rockets. The size and power of Starship make landing much more difficult. The Super Heavy booster alone is as tall as the entire Falcon Heavy rocket. The Starship's payload capacity is also impressive. While the Falcon 9 can carry up to 22,800 kilograms to low Earth orbit, Starship can carry up to 150,000 kilograms to low Earth orbit and more than 21,000 kilograms to geostationary transfer orbit. This surpasses the capabilities of Falcon Heavy, which can carry up to 63,800 kilograms to low Earth orbit. However, with this increased capability comes increased complexity in landing such a massive structure. SpaceX isn't just going to drop the rocket into the ocean, they will perform many tests before landing the rocket. One of these tests is the belly flop maneuver, where the spacecraft flips over and re-enters the Earth's atmosphere with its belly facing down. This maneuver allows for a controlled descent and landing, similar to a skydiver. To simulate this maneuver, SpaceX will drop the Starship into the sea. The orbital landing test flights did not start with straight up and down trajectories, as the first prototype test flights were much more challenging. To be safe on re-entry, the spacecraft needs to re-enter the atmosphere somewhere on the other side of the ocean. If something goes wrong, it will cause problems for the experimental spacecraft. SpaceX has carefully considered landing the Super Heavy booster in the Gulf of Mexico. The rocket's flight path over the ocean ensures all debris will fall into the water if something goes wrong. The final splash point is a safe distance in the Indian Ocean, although this location is not under U.S. jurisdiction. This method is the best way to ensure human safety and increase Starship's success rate. The belly flop maneuver involves the spacecraft using its large surface area to create significant atmospheric drag, slowing down its descent without using much fuel. The Starship has a large surface area on its windward side, which acts as a brake during descent, reducing its terminal velocity significantly. During the belly flop maneuver, Starship's engines draw propellant from header tanks to avoid propellant settling on the belly side of the rocket due to atmospheric deceleration. This ensures the engines have a steady supply of fuel even as the rocket falls belly first through the sky. Another reason SpaceX avoids catching Starship midair with Mechazilla is to protect the ground infrastructure. Starship is still experimental and needs more tests before attempting an air capture. Any additional hardware around the launch pad could suffer significant damage if things go wrong. Some people might see the ground infrastructure as just a concrete slab, but it's much more than that. The launch infrastructure includes complex and expensive components such as the launch tower, fueling systems, and control centers. These facilities are vital for the safe and efficient operation of the rocket launches. We can see the significance of this from the first flight test when Musk said anything that doesn't damage the launch tower is considered a success. This statement underscores the importance of the ground infrastructure in SpaceX's operations. The cost of the ground infrastructure can be immense. For example, building a launch pad can cost anywhere from $50 million to $200 million. The risk of an unsuccessful midair capture could lead to catastrophic failures, potentially causing the rocket to veer off course and destroy the launch tower or other critical systems. Given the size and power of the Starship, any mishap could result in extensive damage. The Super Heavy booster, which is part of the Starship system, stands at 70 meters tall and generates 72 million newtons of thrust. That's all for today's update. If you enjoyed watching and found it useful, please subscribe to our channel and hit the like button. Thanks for watching, and I'll see you in the next one.